One more pair of an example and you try before we're done with these video notes. So now I want you to evaluate this whole thing right here. Let's kind of interpret what this means. I want you to evaluate the sum from k equals 1 to 40 of 2k minus 3. Now this seems a little bit complex. Before we were dealing with sigma notation, we were just kind of expanding and evaluating, but now you can see I'm adding up to 40 terms, and that's going to take us a long time. So what I need to do is I need to kind of extrapolate the important information in this sigma notation to see if I can't use one of my formulas that we were looking at before for my series, my arithmetic series. First thing that I'd say is we have to kind of know that this is arithmetic. And the giveaway here is that I have this 2 times k. In this case, this 2 gives me my common difference. This is my D. And kind of like the hint or red flag or bell ringing for this to kind of show me that this is my common difference is remember that arithmetic is when we're adding or subtracting the same amount, and that should remind us of like linear functions, linear equations. So the fact that this looks linear is what tells us that this is arithmetic. So if this were a 2 to the k power, that looks kind of exponential, now we'd be talking about geometric. But because this looks kind of linear, that's where the arithmetic comes from. So really it's a good idea to kind of put those two thoughts in your mind. Arithmetic and linear are very closely related to each other. All right, so this is my common difference. The 40 gives me my n value. So I've got a D, I've got a 40. Now the other pieces of information I'd like to have would be u sub 1. And it'd be nice if I could find what u sub n is, but I don't really need the u sub n since I can use that first formula. So u sub 1 is going to be given as when k equals 1. So that's going to be 2 times 1 minus 3. So it looks like u sub 1 is equal to 2 minus 3, which is equal to negative 1. So now let's use that formula. S sub n equals n over 2 times 2 u sub 1 plus n minus 1 times d. All right, so since I know all of this stuff, I'm going to choose to use this formula. So in this example, I want to find the sum of a 40-term series, and that's going to equal 40 over 2 times 2 times negative 1 plus 40 minus 1 times my common difference, which is 2. All right, so let's kind of work this out. S sub 40 is going to equal 20 times negative 2 plus, this is 39, times 2. So S sub 40 is going to equal 20 times negative 2 plus 78. So S sub 40 is going to equal 20 times 76. And if we multiply those two numbers together, S sub 40 is going to equal, see, 2 times this will be 152, and throw a 0 on that, 1,520. So hopefully I did that math okay. Check me if I made any errors in my arithmetic here. But basically the big kicker for this one is plugging in these values into my equation, but kind of recognizing where they come from in the sigma notation. Now, before you try the next example on your own, I want to reveal a little bit of some calculator trade secrets with you. I can actually evaluate this on the calculator with the TI. So depending on which calculator you might have different button presses than me. But if I go to math on my calculator and scroll all the way down until I find this summation and hit enter, you'll see I've kind of got the framework for entering in exactly what this is as it's written. So again, you can hit the math and then go down to summation. Some calculators, if you get the really fancy ones, if I press alpha and then F2, this brings up kind of like a hotkey tab where I can choose summation right from here. So let's kind of plug in what we're looking for our summation. We can plug it in just as it's written. I'm going to use an x instead of k, but I'm going to start with x equals 1, and I'm going to go all the way up to 40. And I'm summing the general term 2x minus 3. And we'll see if I did that arithmetic right. I add them up together, and sure enough, I do get 1,520. So this would be a great calculator problem if you have a calculator that can do this. If you don't, or if this is on a non-calculator part, you can do the process that we just talked about here. So why don't you do that actually? Why don't you try this example here? Try it out by hand first, try to identify those important pieces, and then check your work using the calculator. And here is the final solution for this one. You have to kind of identify your u sub 1, your common difference, and your n value, and then you can plug it into the formula, and you should come out with something like this. And then you should also be able to verify this using your graphing calculator.